Hello everybody, welcome into another lesson. So today is going to be the start of a series about square roots, otherwise known as radicals. So today's particular lesson we're going to talk about irrational square roots. What I have up here are examples of what are called rational square roots. As we know, a rational number is a number that can be expressed as a fraction in the end. So an irrational number cannot be expressed as a fraction. But, for example, we take the square root of 4, we get 2. Take the square root of 25, you get 5. Take the square root of 81, you get 9. Those are examples of perfect squares, which are those are rational square roots. But what we're here to talk about today are irrational square roots. I didn't see a need to teach a lesson on rational square roots because we've already dealt with those in pre-algebra and even a bit in basic math. So let's talk about irrational square roots, which is really what you're here for today. Let's say we have something like the square root of 63. Well, we can tell you already that there is no number times itself that equals 63. No whole number times itself anyway. And if you take it with a calculator, you're going to get some ugly decimal number it's non-repeating, but it's also non-terminating. It just goes on and on forever with a bunch of random digits. So this is going to lead into something bigger with doing arithmetic with these type of numbers and even some algebra with them, but for today, I'm going to teach you how to express them without having to break it down into decimals. So, we have the square root of 63. What are some factors of 63? Well, 9 and 7, right? You could take the square root of 9 times 7. Then, what you can do, whenever you have multiplication inside of a square root, it breaks down into the square root of each product times the square root of the other product, of the other number. So, two numbers that are being multiplied inside of a square root are separable into their own square roots, multiplied by each other. So we have 9 and 7 as factors, right? Well, there's no square root of 7, but there is a square root of 9. There is a perfect square root of 9. The square root of 9 is 3. So you'll have 3 times the square root of 7, or it could be written as 3 times the square root of 7. And that's really all we can do with it. Without breaking out decimals, square root of 63 turns into 3 times the square root of 7. Let's do another one here. How about the square root of 28? So in this particular one, we have the square root of 28. Again, we know 28 is not a perfect square, but this can become, we have a factor that is, we take 4 times 7 inside the square root, which means this can separate into the square root of 4 times the square root of 7. Well, square root of 7 is not a perfect square, but the square root of 4 is. It's 2. So the answer to this is you would get 2 times the square root of 7. That would be your final answer for this. It would be 2 times the square root of 7. That's what it'll break down into. Alright, how about we have here the square root of 98. So we've been given the square root of 98. Again, 98 is not a perfect square, right? But we can make this into two factors where at least one of them is a perfect square. We have, for example, 49 and 2. Those are factors which will break down into the square root of 49 times the square root of 2. Well, square root of 2 is not a perfect square, but the square root of 49 is. It's 7. So what you'll end up getting in the end is 7 times the square root of 2. And that would be your answer, 7 times the square root of 2. how about we'll do the square root of 50. So we got the square root of 50 here. Well, again, 50 is not a perfect square, but we can break this down into two factors where at least one of them is. Well, 50, most obvious, you have factors of 25 and 2, which will break down into the square root of 25 times the square root of 2. Well, square root of 2, again, not a perfect square, but the square root of 25 is, that's 5. So you would end up getting, for your final answer, 5 times the square root of 2. So square root of 50 is equal to 5 times the square root of 2. All right. How about the square root of 75? So we have here the square root of 75, which we also know is not a perfect square. However, we can break this down into two factors where at least one of them is a perfect square. You can do the square root of 25 times 3, because 25 times 3 is 75. And then now this will separate into the square root of 25 times the square root of 3, which we know the square root of 3 is definitely not a perfect square, but the square root of 25 is, it's 5. So your final answer for this problem should end up being 5 times the square root of 3. That's exactly what you would get, it's 5 times the square root of 3. All right, how about the square root of 24? So we have the square root of 24 on our hands. Again, 24 is not a perfect square. But again, we can break this into factors that are at least one of them is a perfect square. I'm thinking we do 4 and 6. This will become the square root of 4 times 6, which will separate into the square root of 4 times the square root of 6. Now, let's see, square root of 4 we know is 2, right? Square root of 6, the only factors for it besides 1 and 6 are 2 and 3, and neither of those factors are perfect squares, so we can't reduce the square root of 6 any further. So in the end, you'll end up getting 2 times the square root of 6. That would be your final answer, would be 2 times the square root of 6. Okay. Now here's a new term for you. What if I had something like 9 times the square root of 90? So this just changed. We have a coefficient on the square root. We have 9 times the square root of 90. How are we going to do that? Well, what I'm going to suggest is you take that 9, then multiply it by some parentheses. Keep that 9 outside of the parentheses. So forget about your 9 for a minute. Focus on factors of the square root of 90. Well, we know we can have 9 and 10. 9 and 10 are factors of of 90, which we know this will turn into 9 times the quantity of the square root of 9 times the square root of 10. Okay. Well, square root of 10 is definitely not a perfect square. Not even one of the factors has a perfect square. So the square root of 10 cannot be reduced any further. But the square root of 9 is 3. So what you'll have is 9 times 3 times the square root of 10. Now all you're going to do is take that 9 and multiply it by the coefficient on the square root. 9 times 3, that would end up giving you 27 times the square root of 10. So your answer for this should end up being 27 times the square root of 10. And I do have more examples like this. All right. How about 6 times the square root of 45? So we have one here, 6 times the square root of 45. Again, start out, make yourself some parentheses here, keep 6 outside of the parentheses, because this is really 6 times the square root of 45. This will be 6 times the square root. Let's find factors of 45. Well, how about 9 times 5? 9 times 5, those are factors of 45, which we know this will separate into 6 times the quantity of the square root of 9 times the square root of 5. Well, we know the square root of 5, that's not a perfect square. But the square root of 9 is, you end up getting 6 times the quantity of 3 times the square root of 5. So you have 6 times the quantity of 3 times the square root of 5. Now you just multiply the 6 times 3, and you'll end up getting 18 times the square root of 5. And that would be your answer, would be 18 times the square root of 5. Alright, so we have 14 times the square root of 75. Okay, so what we're going to get now, we have 14 times the square root of 75. Again, form yourself some parentheses for the square root of 75. Keep the 14 outside of the parentheses. Now, square root of 75, factors of 75 would definitely be 25 and 3, would it not? Which we know will have 14 still outside of the parentheses, but the square root of 25 times 3 can separate into the square root of 25 times the square root of 3. Well, square root of 3, that's not a perfect square, but the square root of 25 is. That's 5. So what you'll end up having is 14 times the quantity of 5 times the square root of 3. We're almost done. All you got to do now is multiply 14 times 5, which should give you 70. So the answer you would get for this is going to be 70 times the square root of 3. That's exactly what you get, 70 times the square root of 3. This is much more convenient than trying to do this in decimal form, because we know from previous courses of trying to convert these to decimals in a calculator, it's quite hideous. Alright, how about we have 10 times the square root of 125. So we are now given 10 times the square root of 125. Well, 125 is not a perfect square. However, like we have with the other problems, keep 10 outside of your parentheses. Let's come up with some factors of 125. Well, we know there's 25 times 5. 25 times 5, those are factors of 125, which this will separate into 10 times the quantity of the square root of 25 times the square root of 5. Which we know the square root of 5 is not a perfect square, but the square root of 25 is, that's 5. So now you're going to have 10 times the quantity of 5 times the square root of 5. Which when you multiply 10 times 5, you'd end up getting 50 times the square root of 5. And that would be your answer. You'd end up getting 50 times the square root of 5. Alright, let's do one more. How about 3 times the square root of 160? So we have 3 times the square root of 160. Well, what we're going to do first, take 3, put it outside of parentheses, take the square root of some factors of 160. What are some factors of 160? Well, certainly 16 times 10, right? 16 times 10 would give you 160. Well, now this separates into 3 times the quantity of the square root of 16 times the square root of 10, which, as we know, 10 is not a perfect square, nor are any of the factors of 10, but the square root of 16 is a perfect square, it's 4. So you'll end up getting 3 times the quantity of 4 times the square root of 10. So all that's left now is multiply 3 times 4. You'll end up getting 12 times the square root of 10. And that would be your answer, would be 12 times the square root of 10. So really there isn't much to it. If you can remember that factors inside the square root, they become separable and they become their own square roots on their own, you got this. There's not much to it. Next lesson, we're going to talk about square roots of variable expressions, how we deal with those. So I hope everyone has a good night. Take care.